Hey guys, Neutron Star here. Today I'm going to show you how to make hydrochloric acid. Hydrochloric acid is another common lab acid. It has a wide range of uses. In my opinion, it's the most useful acid among all acids. Different from sulfuric and nitric acid, which is liquids, hydrochloric acid is an aqueous solution of hydrogen chloride gas. We're going to generate the gas by an anion single replacement reaction of sodium chloride and sulfuric acid, then let the gas dissolve in water. If you don't have sulfuric acid, you can also use sodium bisulfate, which contains bisulfate ion that will also react with sodium chloride. Just a quick warning here, sulfuric acid and hydrogen chloride are both corrosive. Proper PPE must be equipped. Making hydrochloric acid this way is only worth it for you guys who don't have access to it. If you do, then buying it directly will be a better and cheaper choice. To start off, I put 50 grams of sodium chloride into a round bottom flask. On the other side, I poured about 90 milliliters of distilled water into the receiving flask. Then it's connected to something really similar to a distillation apparatus. However, the entire middle part serves as a gas transferring tube. You might notice that I connected the tube to the inner end of the vacuum adapter. This will pump the HCl gas formed directly into water and help it dissolve. To increase the solubility of HCl in water, putting ice around the receiving flask is recommended. I didn't do it here because the temperature is already low due to the cold weather. When everything is good to go, 30 milliliters of my 90% sulfuric acid was added to the round bottom flask. This immediately triggered the reaction and a lot of hydrogen chloride gas was produced. When I was removing the funnel, some white fumes came out. The fuming occurred due to the HCl gas dissolving in moisture in the air and created small particles of hydrochloric acid. The hydrogen chloride gas quickly came through the tubes and started dissolving in the water. One sign of the dissolution is that some distortion effects is seen in the solution because as the gas dissolves, the density of the liquid isn't uniform, so the way light refracts is different in different places. This causes light waves to bend in different directions, creating a distorted image in your eyes. I added some additional water to the receiving flask because I think 90 ml can't dissolve everything, but this ended up diluting my product. The bubbles in the round bottom flask lasted for a while and died down. I started the heat to trigger the second reaction. Compared to the first reaction, the second one is much slower and less efficient. I'm not really sure if I could even get half of the yield of the first reaction. I let it run for 2 hours and it looked dry when I came back, so I ended the reaction. A very important thing to know is to prevent suckback from happening. Suckback usually occurs at the end of the reaction, when there isn't new gas forming and a lot of gas is dissolving into water. The volume of gas decreases at the receiving flask, hence pressure decreases. The liquid will be sucked towards the reaction flask due to the pressure difference. To prevent suckback, you can add another empty flask in the center like Nerd Rage did, or you can occasionally release the pressure like I did. Even if it's all sucked back into the reaction flask, it's not a big deal because you can just distill it over. I carefully disassembled the apparatus and ran a classic density test on my product. Basically, you measure the volume and mass of the hydrochloric acid and get its density. Then you can find the concentration on the table online. I got a concentration of about 21%. If you want your acid to be more concentrated, do not run the distillation since hydrogen chloride forms an azeotrope with water at a 20% concentration. Instead, run the reaction again with your dilute HCl in the receiving flask. Now comes the fun part, where I tested the acid I just made with some aluminum foil. Several aluminum foil balls were dropped into the acid. At first, it seemed like nothing was happening because the acid had a hard time dissolving through the thick oxide layer on the foil. Once the oxide layer is removed, a violent reaction took place, and I think it is pretty cool. Okay, that's all for this video. Thanks for watching. I hope you've learned something, and I will see you on the next one.